This is our presentation for Hopper Hacks 2023. What our project is going to be a handwriting analysis website, and it's just going to be a little Python script that analyzes your handwriting according to um, the studies of graphology. So this is our table of contents for this presentation. We're going to talk about the project background on why we're doing it and how we think it's going to affect the community of graphology. We're just going to go over what graphology is and how we wanted to implement it into a algorithm. Then we're going to talk about the approach that we use to automate the analysis. And then we're going to talk about the upcoming features and long-term goals past this hackathon for this project. So the project background is um, that we really wanted to show graphology to a lot of people. As me personally, I found out about graphology while trying to improve my handwriting, and it's a really fun community, but it's a very niche and small one, and it is um, very important for this community to grow since it's showcasing how handwritings are formed and how our mood and our personality changes how we write. And we wanted to make this project so we can let newcomers to try out the field and hopefully they get more involved. So the key parts about graphology are going to be the pressure, the baseline, the margins, the slant, and the zones of your handwriting. So the pressure is like how thick your handwriting is, how bold and how dark it is. And then it can tell you various things about your personality. And it's the same for all the groupings. The baseline is the if your letters are going in the upwards direction continuously or is it going downwards? And we base that off the first letter. And we put a line underneath it to see which way it goes. The margins is how close your handwriting is to either side, also to the top and bottom. And we also going to look at how it covers the space. Does it cover the space evenly, or is it like a lot of dead and white space? The slant is which way the letters are facing. So you can write right slanted or you can write left slanted, and they tell various things about your personality or your mood. And is different from the baseline since the letters are not going upwards. It's the letters are slanted, but they're still on the same row. The zones are the founding blocks of graphology. So there's three zones: the upper one, the middle, and the lower. The lower is usually where like your G's, your Y's, anything that goes below the page. Your middles are like your A's, your D, your E, your I, O, U's, and your upper zones are like F, T's, K's. So it's like when you were learning how to write, you had that little box and with a dotted line in the middle. It's just like that. So each zone tells you stuff about you, and the bigger one zone is and the smaller one zone is, it tells you on your mood or your personality. So our approach was using OpenCV and then use algorithms to get to analyze the data that we got from OpenCV. So one of the major things that we needed to do was the pre-processing of the data. So first we got the image, we grayscaled it, then we blurred it, and we find the edges. So we can only get the contours of the image to see the handwriting on the page. After that, we would use OpenCV functions to draw lines or build bounding boxes, ellipses, and to find the centroids. After that, we group all of that data so we can find each contour on that page, which is corresponding to a letter, and then find that location through pixels, as that's how CV does it. So the top left is 0, 0, and then everything else is going to be a certain amount of pixels away. So for our algorithms for zoning, What we did was we created a line in the middle by finding the sensoroids and then seeing if it's above or below. And if it is, then we're going to create a 2D array of the word, and then we store how many you have in the middle zone, the upper zone, and the lower zone. And then the one with the most tells you that you wrote majority in the middle and that you have like a large middle zone. For the margins, we took a bounded box around the text. Then we saw where it is on the screen according to the image. As with OpenCV, you can get the image dimensions. And then we just took the distance between that and the leftmost side of the bounding box to find how far away is from the left margin. And then if we wanted to do the top, we would take the top of the page and then compare it to the top of the bounding box. For pressure, we kept on thresholding the page by grayscaling it. And as each time you do that, it loses like a part of the ink that is not dark enough since it doesn't meet our threshold. And we did that, and then we put it into a histogram to see, how each threshold changes and how your pressure is like degraded when we make it more binary. For the slant, what we did was we put a rotated bounding box. Then we took the leftmost point of the rotated bounding box and the top point, find that distance, and then take the leftmost point and the bottom of the point and find that distance. And then we saw that if your top distance is bigger than the bottom distance, that means it's right slanted. And if your bottom distance is bigger than your top distance, that means it is left slanted. Then we just went through each letter, and if you have a majority of letters being right slanted, then your word is right slanted. For the baseline, we just took the bottom of the bounding box of the first letter and then compared every other letter in that sentence to it by finding just like the deviation in your y-axis and then averaging that up. And if it is positive, then that means you're going upwards. And if it is negative, then you're going downwards. And this is the reason for that is because the top left is 0, 0. So if I have y, anything below it is going to be greater than y. If I do y minus that, then it's going to be a negative. The future for this is adding just more graphology basics like size, spacing, speed, as we needed to use ORC to like find the individual letters and see if that letter corresponds to like the average size or um, you know, take all the letters on the page and see if it makes up a word, and then we can see the difference between the two words. Because currently there is no way we can check if our word is a word or just a really close letter. There's also speed, which just takes in a video file and then sees how fast the person is writing. And then one of the last things we wanted to do is create an app and make it more accessible and also let you see everyone else's data and compare you to everyone else's handwriting. Thank you. So the GitHub repo is this. You can use the link or the QR code. And after this, we're going to show you the demo of the actual product working.